Hi, this is Lawrence from UP Energy Engineering Program, and this is Introduction to Competing Feedback Loops in Systems Theory. Together with my teammates Alvin and Sheena, we will discuss one-stock systems with two competing balancing feedback loops. In previous discussions, we are introduced to simple systems composing of a stock and an inflow or outflow, or in this case, both. As an example, let's say that we have a bathtub as our stock, and it's being filled by a faucet representing our inflow. And lastly, let's say that there's a hole under the tub that represents the outflow. In this scenario, we previously analyzed that the stock will increase up to the maximum value that the stock can carry when inflow is greater than outflow. It will remain the same if inflow is equal to the outflow, and lastly, the stock will decrease down to zero if the inflow is less than the outflow. We've also tackled in the previous lecture that more complex systems have feedback loops. Feedback loops may be stabilizing, goal-seeking, or regulating, called balancing feedback loops, like the difference in temperature of coffee to the surrounding that leads to cooling, and a feedback loop that is amplifying, self-multiplying, or snowballing, called reinforcement feedback loops, as to the amount of interest that will be added due to compounding. In one stock with two competing balancing feedback loop system, a perfect example would be that of a room temperature being heated by a furnace, with heat leaking to the outside. The two balancing loops in this system are the discrepancy between the desired and actual room temperatures, and the discrepancy between the inside and outside room temperatures. Isolating the two balancing loops, we notice that the furnace will supply heat into the room until it reaches the thermostat setting. While on the other hand, due to imperfect insulation, the heat inside the room will leak onto the surrounding until it reaches thermal equilibrium with the outside temperature. But in reality, the two loops compete with each other for the room temperature. As a result, the heat inside the room will leak outside continuously as the furnace constantly provides heat to reach the thermostat setting. Ideally, if the outside temperature is constant throughout the day, the room temperature will reach a temperature just below the setting. But due to the difference in outside temperature per unit time, the room temperature will curve according to the discrepancy of the inside and outside temperatures. For other examples of a one-stock system with two competing balancing feedback loops, here is Alvin Adorna.
Thank you, Lau. So I will going to present some real-life examples of balancing loop. So first is homeostasis, or a self-regulating process by which biological systems maintain temperature stability. Okay, so in this system, the inflow is the heat from the body, the outflow is the heat to the outside, and the stock is the body temperature. Okay, so the discrepancy between ideal and actual body temperature is regulated by cellular metabolism, while the discrepancy between the body and outside temperature is governed by the outside temperature. Okay, so when the internal temperature of your body increases, you sweat. At the same time, if your body temperature drops, you may start shivering, releasing more heat to warm your body, balancing the initial decrease. So this process in turn maintains a body temperature that is fluctuating a little around 37 degrees Celsius. Okay, so next example of a system undergoing a balancing loop is a predator-prey relationship. Okay, so in predator-prey ecosystems, when the number of predator decreases from the ideal population, they need to consume more of their prey, and the increase in prey consumption gives more predator prey. This prey consumption in turn decreases the number of prey, and therefore decreases also the number of predators due to lack of food. And as shown in this graph, the decrease in number of predators give way again to increase the number of prey. This goes on in a cycle until the number of predators will hopefully approach a sustainable level that ecologists call the carrying capacity. Okay, so next example is the grid stability through frequency balancing. Okay, so the frequency of an electrical grid is governed by the demand and supply of electricity. So in the Philippines, the standard frequency is 60 Hz, and any deviations from that worsens the reliability of the grid. Okay, so the inflow of the system is the increase in generation of supply. The outflow is a decrease, and both of them affects the grid frequency, which is the stock. The discrepancy in the positive feedback is governed by frequency control actions, and the discrepancy in the negative feedback is fixed by under frequency load shedding. Okay, so this is an example of sudden loss of generation, and the frequency is instantaneously deviated from 60 to 59.9 Hertz. This is fixed by grid operator by automatic shedding of loads or demand. Okay, so the highlights and conclusion will be discussed by Ms. Sheena.
Now, let's take a look at the thermostat general principle. Meadow says the information delivered by a feedback loop, even non-physical feedback, can only affect future behavior. It can't deliver a signal fast enough to correct behavior that drove the current feedback. Even non-physical information takes time to feedback into the system. Looking at the house covered with snow, having multiple openings and composition of material used, this house terribly needs a heating mechanism to make the occupants inside feel comfortable. To just put a heating system inside, but a lot of consideration needs to be taken for the stock in here the house to establish desired temperature. If we consider each balancing loop individually, the condition factors that affects are 1. Room temperature versus the thermostat setting. The person can set the temperature too high or just enough. Because on how the person feel is subjected and differ to every person, maybe fat or the person is slim, then the furnace efficiency can be an old or new equipment that can either respond easily under requirement. Factor of the improper design could be over or underloading, as well preciseness of the data that this instrument collects that makes control of the furnace. On the second balancing loop, heat supplied will go higher and find way to go out of the stock in here the house, probably on the ceiling or any opening. Then the factor of the coldness outside will find way to enter the stock and translate to become an additional load that the furnace needs to handle to make the stock or the house warm. This is in lieu of factors of the insulation installed from the type of material and its structure and way of installation that will affect the loop. Going back on what Meadows says, a person in the system who makes a decision based on the feedback can change the behavior of the system that drove the current feedback. The decision he or she makes will affect only future behavior. Why is that important? Because it means there will always be delays in responding. It says that a flow can't react instantly to a flow. It can react only to a change in a stack and only after a slight delay to register the incoming information. These factors create an interconnection that feed information on what the person could possibly set on the thermostat setting that then affect the future behavior of these two balancing loops. So as a summary, first, the balancing loop will try to bring back stock to desired level as it is goal seeking. Then thermostat system comprises of one stock with inflow and outflow. And this inflow and outflow is regulated by the balancing feedback loop. There are two parameters for each balancing loop that sort of dictate the behavior of in and outflow. These two parameters are in competition based on actual with each other. In the system, two feedback loops that indicates the difference between actual and desired level and keeps a single stock moving towards the desired goals. This feedback loop then in keeping the stock in the desirable range and gives it a standard level of consistency. Treating the loops individually is what is ideal, but on actual factors that is interconnected and gives information, considering delay in delivery that could influence only future behavior of the stock. Thank you.